This is a problem from one of your lab assignments from section 2.2, and they're asking us to investigate the following limits. We have the graph here for us, which is kind of cool and interesting, and we want to know what happens. We want to know what happens as a limit as x approaches 0. You can see there's a lot of stuff going on here. That's kind of weird, but let's see what happens. We have sine 5x divided, or 5 pi divided by x, sine 5 pi divided by x. So it gives us a solution, but they're asking us to put in some values. So the function f of x equals sine 5 pi over x is undefined at 0, so we can see that there's an issue there. Evaluating the function to some small values of x, we get whatever values that we're going to get here. So when x is equal to 1, we have sine 5 pi. I don't know what sine 5 pi is. Actually, you should know, because this is a sine function, and the sine function, let's call on Desmos to have us graph the function. And I'm just going to put sine x, and let's look at 5 pi. So this is 0 pi, we need more room here, 0 pi, 2 pi, 3 pi, 4 pi, and 5 pi. Looks like it's going to be 0. Oops, that's 6 pi. This is 5 pi. So it's going to be 0. So it looks like this is going to be 0. Um, 15 pi. So if we take that graph and keep going to 15 pi, it looks like every time we have a multiple of pi, we're going to be at 0. So I think this is going to be 0 again. 50 pi is 0. 10 pi is 0. Sine of, if we put 1/4 in here, we get 5 pi divided by 1/4. So, you know, 5 pi divided by 1/4 is like saying 5 pi times 4, so that's 20 pi. And then that's also 0. And it looks like 500 pi is also going to be 0. So, similarly, if you put 0.00001, as we see that these are numbers that are getting closer and closer to 0, we're going to get 0. So it looks like we're tempted to say that the limit as x approaches 0 is 0. Okay, but our guess is wrong. Note that although f of 1 over n equals this expression, and now if I look at the angle and the sign here, this is a multiple of pi. This is 5 times n times pi. And anytime you have a whole number here, here it's just multiples of 5, but actually, you know, 3, 7, and other numbers that are not multiples of 5 is also going to generate us a value of 0. Right? So all these values are values of 0 as long as it's a whole number times pi. So anything for any integer n, this is going to be 0. It's also true that f of x is equal to 1 for a bunch of values just by looking at the graph up here. So looking at that graph, it hits 1 a whole bunch of times as you get closer and closer to 0. So the compressed lines near the y-axis indicate that the value of f of x oscillates between 0 and 1 infinitely as x approaches 0. So since the values of f of x do not approach a fixed number, then x approaches 0, then this thing must not exist. Okay? So what we're trying to say is that our graph does not settle on one particular value. This thing just oscillates wildly as it gets closer and closer to 0. So, okay, I think that's what they're looking for. We'll submit, and we'll see that that's okay. You can take a look at the textbook for in section 2.2, example number 4. You'll see something similar to this. So next time you run into one of these problems, you can check that out. Okay, I hope that helps.